if anybody have questions about your Julia coding, the line by line homework problem that I gave you yesterday, you need to see your PRT leaders, Wade or Quincy or Micaiah, see them because they know what to do. So for today's homework, that you have to turn it into me, doing a Newton's method, line by line, not really programming everything automatically, but just do line by line that I did in class with you. Okay, so do that. So you can look at a Newton's method YouTube video that we did last week. You can look at that. That has everything you need to know. And what we did yesterday, it's not uploaded yet. So it probably uploaded today sometime. But you can just look at the Newton's method from last week. That will give you all the things you need to know. You need to know to do your homework for today. And about the regarding Julia Academy tutorials, you need to watch that by this Sunday. So you can do your homework, your semester project that you can turn it into me by this Wednesday. The semester project is you have to write a function that takes 4 arguments. Function f, f prime, and x0 and tolerance. And then your function going to do the iteration itself, not manually like we did yesterday. Your program gonna do it automatically, okay? And then whatever the function that I give you, then you're gonna find a f prime, starting x naught, and I'll give you f, I'll give you tolerance, and then you'll choose, and then using that to give me the answer, what the answer is, what the solution is. So you're solving an equation, not algebraically, but you're solving your equation numerically using a Newton's method. Okay, I hope everybody understands what Newton's method is. Newton's method is solving an equation numerically, not algebraically. Okay, algebraically we can solve some problems, but a lot of equations, a lot of functions you cannot solve algebraically. You have to do it numerically. So Newton's method is a very useful. Bruni, you have a question for me?
No, I don't.
Okay. So does everybody understand what to do? All right. So we're going to start our lesson. Today we're going to do chapter 4. So let me share my screen. All right. Let's go into the integration. So we're not going to do any more derivatives anymore. So now we are going to work backward. Okay. So we've been taking a derivative, which means you had a higher, say your function has a degree 5. Okay. Then when you take a derivative, the highest degree become a what? Degree 4, because you take 1 less power of that. Now we are going backward. So if you have an integration, if I give you a function, have a degree of a 4, if I take antiderivative is the same as integration. So they're same word, okay? It's exchangeable. Like I am Dr. Harris, but I'm also what? Mom to my daughter or my son. But I'm not a different person. I'm the same person, right? I'm a Dr. Harris to you guys, but I'm a mom to my children. My children does not call me Dr. Harris. They call me mom, right? Same thing, but I'm not a 2 different person. I'm a same person. Same thing, integration, antiderivative, they're same thing, all right? It's interchangeable. So antiderivative means I'm going backward to derivative. I'm going back to the function that was supposed to be. So I have a function, the degree 4. It says take antiderivative of this, then it comes over here, right? That means this function now becomes a degree of a 5 because you're going to add 1 more. Remember, taking a derivative means what? You take 1 less power to come down here. Now I'm going to go up. So that means I'm going to take antiderivative, means I'm going to add 1 power to go up here. All right, that's what antiderivative is. So antiderivatives, we're going to find some rules and regulations. So looking at this is a good example right here. It's a simple example. So you have a function. You have a function with a degree 3, right? When you take a derivative, what will happen? You got a degree 2, not just that, what did you do? You multiply, right? You multiply 3 and then what? X to the 3 minus 1, you take a 1 less power. So we gotta go backward. That's what antiderivative is. A function f is antiderivative if of f, or interval I, f prime of x is the same as f of x for all in x in I. So let's look at an example. So actually, one more thing you need to think about it. So the derivative, okay, derivative, let's looking at this this is a given example, okay, look at the first equation, this one. When you take a derivative of this, what do you get? If I take a derivative of this, I get 3x squared. And take a derivative of this. F2 prime of x gives me what? Also 3x squared. What about the other one? What about this one? F3 prime of x, we could also give you what? 3x squared. So in other words, when you take a derivative to come down step, right? You get the constant part become a 0. So I have no idea how to go back, exactly which function to choose. So if I take antiderivative of this, all right, that would be 1/2 x to the third, excuse me. I'm gonna show you in a minute, but for now, just watch me. That become 1/2 x to the third, but I'm not sure what to put it in here as my constant term. Is it constant 0? The first case is if this case right here, that case, your constant is 0. But if you're looking at the second case, which is this case, the constant should be -5. If you look at this case, okay, this case, the constant should be what? +97. So I don't know, okay? I don't know what to put it in here, 0 or -5 or +97 or +100 or -1000. I have no idea, okay? I have no idea. So what do you need to do? So we decided this is a group of functions. You're taking an antiderivative. Group of function means f1, f2, f3, f4, f5, anything with constant attack. There's a constant term. Anything with a constant term, that can be true answer to it. So that's why when you take antiderivative of indefinite integrals, you always add plus c, because we don't know what c should be, okay? So this is what they're talking about here. When you take antiderivative, you take antiderivative, which is this plus c. The c stands for any constant terms it may happen to be. All right, so let's look at example. So I'm gonna just go into over here. Let's look at our notebook. So we're gonna do antiderivative now. Sorry about that, it's not up to date. You know, let me just start a new notebook. So the chapter 4.1, okay, we're gonna do antiderivative, which is same as integration. Okay, Okay, so that's what we're doing. So let's look at that. If I give you a function, so f of x equal to, say, x to the 4 plus 7. All right, let's take a derivative of this. So what's that equal to? Okay, somebody tell me what's the derivative of this? Tell me what's that equal to?
4x to the third.
Yeah, definitely. It'll be 4x to the 4 minus 1. So which is same as 4x to the third. Am I right? So we know that. Now, that is taking a derivative. This is taking a derivative. Now, what do I want to do? I want to go back. I want to go back. All right, opposite. Antiderivative means what? Taking a derivative is coming down to get a lower power. Antiderivative means what? Going up, become a higher power. So the rule is, so I'm going to do exactly opposite. Okay, I got the exactly opposite. So used to, I will multiply by my power. So what is opposite of a multiplication? Jalen, what is opposite of a multiplication? Is Jalen here? Or Bernice, what is opposite of a multiplication?
Is it division?
That's right. Perfect, perfect. So that means I'm gonna take this. This is what I had. And I wanna go back. So this is the thing, this is what you have to use. So I'm gonna say, okay, I'm gonna take antiderivative of f prime of x, or I can say antiderivative of 4x to the third dx. That's how you write it down, okay? Antiderivative, the part, the symbol is long s, okay? That's integration. So I'm gonna do exactly opposite of that. So that means I used to multiply, that means I'm gonna do what? I will divide, right? So I'm gonna say, okay, so let's divide it. So I have, I'm not gonna do anything to my 4, right? So I'm gonna leave 4x to the third, and I'm gonna do divide. I will divide it by my power. Okay, now what do I do? And then what do I do? I'm gonna add this 1, now add 1 here. So I'm dividing by my power. Do you see it? I used to have a 3, but I'm gonna do, I used to subtract, now I'm gonna do what? I'm gonna add. I used to divide, I used to multiply by my coefficients, now I'm gonna do what? I used to multiply by my power to become my coefficients, now I'm gonna do what? I'm gonna make my power to be what? Divide by my function. So that's what I just did. Does everybody see what I just did? And then what I'm gonna do, since I'm not really sure what constant I'm supposed to use, I happen to know this is a +7, but I don't know, okay? You have to assume I don't know what constants I'm given to. So I always have to put what? C. So let's see. I'm not gonna worry about the constant part, okay? I'm gonna worry about only the x with some power in it, okay? So looking at that, what do I get? I'm just gonna simplify. So I have a 4x to the what? 4 divided by 4 plus c, which is what? 4 and 4 cancel out. I get x to the 4 plus c, which is what? Same as that. Does everybody see what I just did? So antiderivative just means you're going backward. All right, let's do another one. So if I give you this problem, let's check again. So if I give you this problem, what is my derivative? Marzi, what's my derivative of this?
4x.
Okay, 4 times what? I need to multiply by what?
2.
By 2. And then I'm going to do what? X to the what? 2 minus 1, right? I'm just going to show every step so you can see how you go backward and forward. I'm just taking a direct downward. Okay, next one. Fabian. What's my next derivative? Next term. Because I'm not going to skip steps. I want everybody to see it. There's a 1 power. Okay. So I have 3 times 1 x 1 minus 1. Of course, the last one is just a 0, right? Okay, so that's my antiderivative. So if I just simplify this, I'm going to say, okay, if I simplify this, that means I have 8x plus 3. That's what I have. Okay, so now I'm going to do, this is calling taking a derivative, right? D. So now let's go back. Let's go back. Let's do it. Antiderivative, okay? That's what we're going to do. So that means I'm going to say, okay, let's take antiderivative of 8x plus 3 dx. So you're taking a antiderivative respect to x. That's why you put the dx, okay? So I'm going to do step by step, okay, term by term. So I will do exactly the same thing I did before. So India, help me out the first term. What do I need to do? I have 8x. So what do I need to do?
You divide by 1.
Okay, divide by 1. I already have a 1 power. So what do I need to do to the power?
You add 1.
Add 1. So what do I need to do over here too?
Add 1.
That's right. I am dividing by my power. My power is 1 plus 1, which is 2 now. Okay, so I'm dividing by 2. Okay, Ethan, next one. What do I do with the 3?
You add 3. I mean, not add 3.
Okay, look at this one.
It's at the 0 power right now. So
It used to be 0 power. So 0 power is what I need to add, right? 0. Now what do I do?
you divide it by 0.
Okay, divide by 0 and then what?
You add 1.
That's right, add 1. Just think about this one right here. That's the reason that I wrote down here. When you have a constant term, that means you have x to the 0 power. Is everybody with me? Right here, 1 minus 1. 1 minus 1 is the same as what? 0 power. So you have x to the 0 power. So if you just have a constant like this, you have to think as this is x to the 0 power. All right, now we just, next thing is what? Just simply adding a c. So my answer is 8x squared divided by 2 plus 3 to the 1 over 1 plus c. Or I can simply say 4x squared plus 3, x plus c, which is same as this one. Remember the constant one, I don't know, it's going to be 7. I know for this problem, but remember, I'm not going to always give you the original function, okay? I just know for this particular example, but if I just give you antiderivative, if I just give you a function, say find the antiderivative, you don't know what constant you're going to use. So you always just use c, saying this is a particular function of any function with a constant, any constant. So I'm going to call it c. All right, so now I want everybody to do this problem for me. All right, f prime Okay, so I'm gonna say find antiderivative of the given function. Find me an antiderivative of a given function. So that means what you have to do, you're starting with x squared plus 4x plus 6 and find the answer. All right, do that for me right now. If I say find an antiderivative of the given function, I gave you this function and you put that inside the integrals, okay? So find me this and find me answer for this. Okay, I want everybody to do it right now. I'll give you 3 minutes. I'll put the timer.
Wait, you want the answer or what?
Show me the step by step. Show me. What do I need to do?
So the derivative gonna be 2x plus 4.
X, the 2 plus 1, and then I'll put the 2 plus 1 here. Okay, watch that.
Wait, hold on. Is that the derivative? What you got? Because I think you're doing it different than me.
Okay. Read the problem. I said find a what? Antiderivative of the given function. I gave you this function, so that goes inside where? Inside of my antiderivative. I'm not asking you to find a derivative right now. I said find antiderivative of a given function. So
Okay.
the function I gave you, it is already taken a derivative. So that's why I gave you a problem like this, because I want you to understand what it's asking. My previous problem, this problem is what? Look at this problem. This problem saying this is just a function. And I say take a derivative. And then go back by taking an antiderivative. In this case, so this is your antiderivative, this is your derivative, and then I have to go back to find that, right? Find the f. Now I'm saying is, I'm just giving you this is this. So you can think of this is like f prime. Okay, they gave you prime already, but now you have to find a what? Without the prime. So that's why I gave you this antiderivative sign in the front. Antiderivative sign in the front telling you to go back, go up, upward. Okay, go up 1 step, 1 degree up. That's what they ask. That's what I'm asking you to do. I intentionally write down like this, so you know, you understand what antiderivative and derivative means. When I say take a derivative, you go 1 power, you go down 1 power. When I say antiderivative, what do? Go up 1 power. All right, so let's do that this one. I will do it together with you guys. So what do I do now? Add 1 and 1 plus 1. Next one, plus 6. And I'm going to say x to 0. Add 1. 0 plus 1 and plus c. So if we simplify it, our answer is now x to the 3rd divided by 3 plus 4x squared divided by 2 plus 6x plus c, or I can just say one more thing. So we're done. All right, so I understand you guys got confused because you probably take derivative, didn't you? And then trying to go back to antiderivative. This case, I already gave you derivative. I didn't call it f prime, I just call it function, okay? F prime is a also function, okay? It's a function. Let's do another one.
Can you scoot it down a little bit so I can finish running down the answer?
Yes, here you go.
Thank you.
There. All right, now let's look at another problem. So again, find a antiderivative, okay? Given function. All right, find me this antiderivative. I'll give you 1 minute. So I'm asking you to find what then? Again, answer is what? Antiderivative of x squared plus 2 to dx. That's what I'm asking. So find this for me, right? First thing, I'm just gonna write down my problem, right? Like this. I'm gonna be add 2 as a 2 times x to 0. Is everybody with me? Because whenever they take antiderivative, we write the constant as 2 times x to 0. So now we're just going to apply the rule. So Brent, help me. The first term, what do I do? Add 1 power to the power, right? And what do I do? What do I do now? Divided by exactly same power, 2 plus 1.
Miss Harris,
Yes.
why at the top on the G is X?
Oh my goodness, that's a mistake. If that's a 3, then this should be 3. Okay. Thank you. I just wrote down a mistake. I wrote down wrong. My problem is 3, then this should be 3. Okay. Next one. Brent, continue this problem. So what do I do now? Okay, come over here. So you have a 0. Now what do I do? What's the rule? The rule says what? Add 1 power to your power. And then whatever you wrote here, you're gonna write down in the denominator, which is 0 plus 1. You're writing down exactly same number. And then you do what? Plus C. Okay, this is not hard, you guys, because we're going backward while we already know how to do. We used to subtract, now we add. We used to multiply, now we divide. It's the same thing, but we're going backward. That's why it's called antiderivative, because it's opposite of derivative. So what is my answer then? Let's simplify it. Brian, you can finish it now. So what do you have? X to the what power? How many power? 3 plus 1, what? 4 power.
4.
Divided by what? 3 plus 1, which is 4. Okay, next one. 2x to the how many power?
It's 1.
1 power, that's right, because 0 plus 1, which is 1 power, and divided by 1 plus c. Well, I can just say 1 over 4, x to the 4 plus 2x plus c. So we're done. Good job. Does everybody understand what to do now? Okay, let's look at your homework problem. All right, when you look at your homework problem, does everybody see it? That Julia coding, this one, the single line one, that is due today. All right, so you got to turn it into me by today. right here. It's a due today. And then Julia tutorial, okay? Julia tutorial, that you need to watch it before 18th. Okay, when you finish watching your videos, they will give you a certificate. You need to take a picture, screenshot of the certificate and email it to me. Is everybody with me? You watch your video. When you finish watching video, they give you certificates. Send me that certificate, okay? Take a picture and send me the certificate. So that will give you 100% on your homework. So next one is a semester project. It'll be much easier for you to do after you watch the video because you have a basic concepts of writing a function. You still can work with the PLTL leaders like Wade, Quincy. They already wrote programs before, so they can help you. I'm not sure about Makaya, but she can also help you as much as she can. All right, so now let's look at the homework problem. So find a general solution to the differentiation and check the result of a differentiation. So if they gave you this problem, okay, then you know what to do. In other words, they gave you this function, they're asking you to find what general solution of this. Find a general solution of a differential equation. So this really means same as taking a derivative of 24 t to the fifth dt. That's what they're asking you to do. Okay, find a general solution to differential equation. So this is a differential equation, right? This is the same as y prime over t. That's the function. All right, so this is what that means. So you know what to do. So this case, that means I'm gonna write down just like what that is. And then what do? You add 1 power and 5 plus 1 and plus c. So you're done then. So that's your answer. All right, so that's how you have to do. So find a general solution really means take antiderivative of given partial differential equation. So you do exactly the same thing. All right, this, they're asking you, how about you do step by step? Okay, so first thing, just like when you take taking a derivative, you do same way. They gave you problems like this. You need to write this problem separately, okay? They gave you this problem right here. You need to rewrite this problem as a 9x to the what? -3rd and dx. All right? Well, you can rewrite this problem as to put the 9 in the front and then put x to the 3rd dx. Okay, that's what they did right here. Now what do? The next step would be x to the -3 plus 1, -3 plus 1, which is same as -3 plus 1 is the same as -2. This is same as -2. That's why your answer over here is -2 and -2 over there. All right, and then they're saying, okay, after you do that, what do? Let's just simplify again. So which become 9 to the -2 divided by -2. Since it's a -2, you gotta put in the denominator to make a positive. So that's why this is equal same as 9 -2 x squared plus c. All right, that's why you have this when you simplify it. So does everybody see it? This is your original problem. You rewrite to be like this. you integrate it, and you simplify it. All right, so we have done that problem. Okay, what about the fraction power? You do exactly the same thing, right? 3/2 plus 1, everything divided by 3/2 plus 1. If you want to, you can put in your calculator as is, or you can also do what? X to 3/2 plus 2/2. Because 1 is the same as 2/2. Then it'd be much easier. So that means you got a x to the what? 5/2 and 5/2. And you got to flip it. So you have 2/5 x to the 5/2, and everything else is the same over here. Then you know what to do. All right, so what about this? You got to rewrite this problem also, right? This means x to the what? That's your index. Index is your numerator power. That's the same as 7/8 dx. All right, class? So some of the stuff I don't teach you because I assume you know it, because this is just algebra problem, okay? So you need to rewrite your problem as, if you have a problem with a radical like this, radical like that, you need to rewrite it as a power. Remember, we know how to do power rules. So we know how to do anti-power rules. We don't do radicals. We gotta change the radical into the power rule, powers, so we can take antiderivative or take the derivative. Okay, next thing. This is what you have to memorize, class. I didn't go over here. Okay, this is the part that you need to memorize, okay? So I'm gonna do opposite. Remember, you know how to take a derivative. It's like a derivative of cosine is negative sine. Derivative of a sine is what? Cosine. So you're going backward. Okay, so you can use this chart, no problem. So when you take your exam, yes, you can use your chart. But if you don't know in your heart, it's taking you a long time, so you may not finish your exam on time. So something very simple, go ahead and memorize it, okay? Like derivative of sine is a cosine. So of course, so antiderivative of cosine will be then what? Sine plus c, because they are opposite to each other. So derivative of cosine is negative sine x. So of course, if you have a positive sine x, then what do you get then? Negative, because remember, derivative of cosine gives you negative. So negative cosine, derivative of negative cosine gives you what? Positive sine, because it's opposite. Over here, same thing. Derivative of a tangent is a secant square. So antiderivative of secant square would be able to be what? Tangent. Derivative of secant square, secant x is a secant x tangent x. So of course, that means antiderivative of a secant x and tangent x is secant x plus c. One more. Derivative of cotangent is a negative cosecant square. So you do opposite. So cosecant square will give you negative cotangent. So one more thing. So slide 15 and 16 is the opposite relationship. So derivative to antiderivative. Okay, derivative, antiderivative. So 15 and 16, if you want, you can print out. So when you do your homework problem, so you can refer to this. All right, any questions today from today's homework or today's lecture? So whatever the problems you cannot do, you may ask me tomorrow. Like number 11, you may get to ask me tomorrow probably. All right, so we can do it together. All right, that's it for today's lesson. And please do your homework problem so you can ask me tomorrow. And if I decide to come to school to give my lecture, I'll let you know tomorrow morning. all right? Because I haven't decided, but I may want to go to school tomorrow morning. So I will let you know. But anyway, do your homework, 4.1, so you can ask me whatever you have, any questions you have tomorrow, all right? So we'll have another exam probably next week, I believe, in chapter 4. So go ahead and do your work and watch that Julia video, okay? Just to watch, just get some ideas how to program. All right. Thank you, and I will see you tomorrow, okay? Thank you. You have a good day. Okay, bye.